I don't know which of these you want me to do, but I guess I'll just write them all out. Distance formula. Whoops, sorry. By the way, it's perfectly okay if you did, there are modifications to this formula. You could have x1 minus x2 and y1 minus y1 minus y2. It doesn't matter which order you subtract them in, because when you square it, it's going to make it positive anyway. So it's not like you had to have this exactly. A little bit of caution, and some people use the 2 and the 1 up above. Those really have different meaning than they're like exponents, so be careful about that. What do we mean by x1, y1, and x2, y2? Point 1 and point 2. Let's see, what's the next one? Midpoint formula? Okay, what was number 3? Okay, in order to find the perimeter, what did you have to do? You had to, of course, find what? The length of each side, and then you had to add them together. So let me just grab this. Yeah, I shouldn't have done that. Yeah. Let's get rid of that. Okay, I can use that as my reference now. So to start finding these, what's the length of AB? Well, I'm not going to do all of them, but using the distance formula, and without writing out every bit of detail, I'm just thinking in my head, I'm going to call this one 0.2 and this one 0.1, okay? And so x2 minus x1 is 2 minus a negative 2, which is 4. So 4 squared. And then 5 minus a negative 6 is 11. So we have what? 16 plus 121, which is 137. Anyway, likewise, you would go through and you would find, I'm not going to do them all, but you'd have to find them all separately. AB turns out to the square root of 137. BC turns out to be the square root of 20, which you could simplify as 2 times the square root of 5. AC turns out to be the square root of 85. And then what's the perimeter? The sum of those. Can you simplify that sum? No. This sum?
Yeah, so do you mean add?
S-U-M.
Yeah,
That means add.
Okay, so because I asked you yesterday, I had this, and you're like, okay, now you have to get perimeter.
Right.
And so I was like, okay, so you add, and you're like, yeah, so I added them together.
No, well, that's illegal.
That's why it didn't make sense when I asked you.
Well, yeah. Well, here's what I meant. Here's the perimeter. There's the perimeter. Okay, that is not equal to, what do those add up to? Yeah, you can't do, this is illegal addition. Okay, you can't add things under a root. That doesn't work. And so I hate to say it, but I had to, when I meant add, I meant this. So be careful, you can't violate the rules of roots. So anyway, number 4, what's the length of the median from the midpoint of side AC? From B to the midpoint of side AC. Well, you had to first find the midpoint, and that was part of the problem. What's the midpoint? So the midpoint of, what was it? AC. That turned out to be 1 comma negative 5 halves. And now that you know that, now take that in point B and do the distance formula. And it should have come out, well, yeah. I guess I better do that one. Okay, so here we go. Point B, just to bring things back, was 2, 5. So, distance. x2, I'll call this point 2 and this point 1. x2 minus x1 squared. y2 minus y1. What's 5 minus a negative 2.5? 7.5? Or to be exact, 15 halves? This thing doesn't pick everything up. Okay, so anyway, that's 1 plus 225 over 4, which is that's as good as you could do. Square root of 229 over 2. Now, I thought I made this clear, but I evidently didn't. Notice I haven't used a calculator for any of this. I don't want to see decimals. Okay, we just shouldn't be using decimals. The problem with decimals, you know, how are you going to take the square root of a decimal? You got to use a calculator, and you're only going to get an estimate. See, these babies are right on the schnozola. Perfect. And decimals just don't cut it, okay? And so I didn't say you couldn't use your calculator, but I don't want to calculator answers. That's really important in an algebra class. Anyway, what have we not done? Oh yeah, the factoring. I should show you that one too. How do you do the factoring? Here's what we had for a problem. X cubed minus 4x squared, minus 4x minus 2x squared plus 8. Well, you could have used the divide and conquer to get started here. Could have taken an x out of the first part. Could have taken a minus 2 out of the second part. Cool. See, up until now, I haven't really factored anything, right? Because there's a subtraction. But the cool part is there's a common factor, which I now can take out. And what's left? Okay, now that's not bad, except we're not done. I asked you to factor it completely. You should have said, that guy right there is the difference of 2 squares. So I know how to factor that too. That's conjugates. So the bottom line, final, there we go. Now we got it. X minus 2. By the way, you could have said x plus 2 times x minus 2 quantity squared. That would have been fine. That was a 3-pointer. Number 1, here's the original quiz. Now the point values are out on the side here. So, and the reason for the point values was, that was my estimate of how much work you had to do to get to each of them. Number 3 was 3 points because you had to do 3 distance formulas, and then you had to add them. Actually, it might have even been, I might have even considered a 4 there. The number 4 was a 2-pointer because you had to find a midpoint, and then you had to do a distance. Number 5 was a 3-pointer because, well, you had to do a 2-step factoring job, and then you had to factor it again. So it was like a 3-step problem. Okay. Well, anyway, we got one quiz. There will be, in this class, there's going to be a pile of quizzes, especially in trigonometry later. But and there may, I never I never know this at this point, but I might drop the little quiz, possibly. I don't do that with tests, but I might drop the little quiz. Or I might do a replacement thing or something like that, but I'll keep you up to date as we move along. Yep.
Can you go back to form one more time?
Yep. What was that? Oh yeah, the length of the median from B to the midpoint of AC. Okay, so did you get for the midpoint 1 comma negative 5/2?
Yep,
Cool.
the only thing that's confusing me is for,
Mm-hmm.
okay, you have midpoint AC is 1 and a negative 5/2.
Right.
Then for the formula, you have 1 squared plus 15 squared over 2 squared.
Right, because what that is, this is x2 minus x1, so that's 2 minus 1, which is 1 squared. And this is y2 minus y1. 5 minus a negative 2.5 is a positive 7.5, or 15 halves. So that's where I got that 15 halves. You're subtracting a negative, so you wind up adding.
Yep, okay.
Yeah. All right. Now, let's move away from this. Let me save this and open up the new thing, and then we'll open it up to questions. Somebody asked me, can we go through, sample problems from the Chapter P test, and the answer is yes, we can. So let me go back to pre-calc 1-1. Okay, so go ahead. You wanted to do one of those samples. Which one? 85. This is from the review exercises on P. 85. Yeah, that's a good one. Okay. So I'll just say P review. Number 85. 3a over a squared over x minus 1. And then that's all over a over x minus 1. Okay? So we definitely have a complex fraction here. And, I could do the invert multiply thing right away. Maybe I should. Why don't we do that first? So let's first rewrite this instead of as a division problem, as a multiplication problem. So then we would have 3a over a squared over x minus 1 times this whole thing over 1. So can everybody, I know that's still really messy, but can you see that first step? Now, the most of the problem is we got to do something about this guy down here and this guy up here. We got to get a common denominator, right? How can we get a common denominator here? Well, let me just rewrite this a little bit. I'm going to put, instead of just a 1 there, I'm going to write it like this. 1 is the same as 1 over 1. So to get, obviously these two cannot be combined right now. Why not? They don't have a common denominator. So let's get one. All I need is x, right? So if I need an x, no problem. I just need to do that on both top and bottom. Don't I need to do the same thing up here? I need an x down here too. So does everybody see that that would be the next thing? All right, what does that give me? 3a. Now I can bring this together because I have a common denominator x. And up here, now I can bring this together because I have a common denominator x. You know what? I didn't do that right, did I? There we go. On the top here, that would be a minus x over x. And on the bottom, we have a 1. Okay? All right. Now, don't I still have one thing divided by a fraction, so I'm going to invert and multiply? And I'm going to pause here because I did a couple things, and I'm going to make sure you know what I did. You know, this second fraction over 1, do I even need the 1? Something over 1 is itself, so that's what I did here. I just rewrote it. But over here what I did is I have one number divided by a fraction. So I took that same number and multiplied it by x over a squared minus x. So that brought the x up with the 3a and left this downstairs. So are you seeing how I got there? Can I cancel anything? Excuse me. Can I cancel anything? I could cancel x's, right? Is that, what were you going to say?
Why is the x even 3a?
Okay, you got... Doesn't that really mean... Would you agree with that? And isn't that the same as... And then if you bring that together, don't you just get 3a? Okay, that's how I got that. Is there anything I can do to simplify that answer toward the bottom there? I could cancel x's, right? This is a factor up here, and that can be canceled, and this is a factor here. So, is there any other thing I can do?
A squared minus x and make it a minus x times a plus x.
I could do that only if the x was squared. If that said a squared minus x squared, you're right, I could do the conjugates. But because that x is not, it's really tempting, I can't factor it. So unfortunately, that's all I can do. So now, I don't know what the best form is. I think I would just leave it like this. That leaves us with, and I really can't do any, I mean, I could multiply that top out, sure, but it's not necessary. So that's where I would leave number 85. Oh, you just made me think of something else. Thank you. Megan, you had suggested something about that, what do you call it, that solutions manual. I thought about it, and I really couldn't just put it in that room. I just didn't think we'd have it very long. I mean, stuff like that just gets lost. So, but what I did is something very similar. I put it in the library on reserve. So, if any of you just goes to the library desk and say, can I have the Math 120 study guide? It's there. I took it in there, and you can make use of it, and I think you have up to 2 hours to make use of it. Some of you may have went ahead and bought your own, but if you don't have one, so what that, you're probably wondering, what is that? Okay, it goes through step by step the solutions to all the odd numbered problems. And since I generally assign odds, then you can go there and go, boy, how did I do? And instead of just having an answer, which sometimes are kind of hard to reconcile, now you can see step by step how they got there. And it could be a valuable tool. That's the best I could come up with. So if you go to the main desk and say, there's a book, you know, I need the Math 120 solution manual, they'll let you can use it for like up to 2 hours. Yep.
Can we do 25?
Yeah, on that, yes, you bet. 25 is next. But I forgot to mention that, and I didn't forget about what you had suggested, Megan. So I hope that's going to work. 25. 6 times the quantity. 4 minus 2 times the quantity. 6 plus 8. Well, the big thing here is, what do you have to do first? You've got to do the innermost parentheses first. What's next? Got to do this multiplication, right? So it becomes 6 bracket 4 minus 28, which is, and now I got to do what's in the brackets next. So now I finally have 6 times negative 24. So that's what, a negative? 144?
So you only multiply like 14 by just the number right next to it?
What, when there's no operation, and you multiply, and you guys, this is corny, but I'm going to throw it out anyway. Have you ever heard please excuse my dear Aunt Sally? Yes. Yeah, so please stands for parentheses. So PE, please, parentheses, top priority. E, excuse, exponents, second priority. Third, my, multiplication. Next, dear, division. And by the way, they're really no priority. M and D are tied. And then after that, we got Aunt Sally, addition, subtraction, and A and S are tied. So it doesn't matter if you do an addition or subtraction, which one, but they come after doing multiplications and divisions, and then those come after doing exponents, and the top priority always goes to parentheses. So anyway, why did I have to do the multiplication by 2 next? Because multiplication comes before addition or subtraction. Yeah. Okay, I don't care. I guess it's, since we didn't give you a new assignment, probably all the questions would be on the test, wouldn't they? Yes.
When you go through one like 90, I personally like the section like P6, but I couldn't find that.
Well, I'll try to make one up then. That's okay. So this is, let me just say, like 94. So let's see if I can do that. Okay, 94. Yeah. You're supposed to insert the missing factor. All right. Well, let's say x over square root of x minus 1 minus the square root of x minus 1. And that's equal to, 1 over the square root of x minus 1 times missing factor. What's that?
For your answer, 1 over the square root.
Is it supposed to have changed the sign? Well, no, in the book, in 94, all the roots have a plus in them, right? All right, I'm trying to come up with something like it. So what I did is I made all my roots with a minus. So you're right, it's not the same, and I didn't want it to be the same. Okay, we're ready to begin. What are we going to do here? Well, what I think the way to do these is to work on, you got to work on the left side. See what you can come up with on the left, and then let's see how that compares with the right. That's my approach. All right, well, don't we need a common denominator to bring these together? So in order to achieve that, wouldn't I need to do something with this denominator, and wouldn't I have to multiply by the square root of x minus 1? Okay, so I don't have a lot of room, so I'm going to multiply both top and bottom by, and of course that makes it legal because I'm doing it to the top and the bottom of the fraction. So what does that happen? What happens now? The left has a common denominator, right? And what's this going to become right here? What's a square root times itself? This is kind of cool. When you take a square root times itself, doesn't it wind up being that thing without the root sign? So really, this turns out to be x minus 1. So now, this numerator is like this. Okay, now carry out the parentheses, and what do you get on top? Well, what's x minus x? Nothing. And when I subtract the negative 1, I get a positive 1. So look at what I get on the left side. Okay. Now, look over to the right. What number in the box will make this true? In this case, 1. Now, I'm not saying I'm not telling you the answer, but and maybe I made this too much alike. I don't know. But that's the idea. So on those problems where they have this missing factor, you got to work with the left side because that's where you got all your information. Just try to get it to a point where you simplify it in any way you can, and then when you get simplified, compare what you've got with what's on the right. In this case, it was an easy last step, but okay. I maybe made that too much alike, but so be it. Yes? 66. Okay, find a polynomial that represents the total number of square feet for the four-point show. Okay, to find the area of a rectangle, you need to take length times width. Yeah, well, polynomial won't be an equation. It would just be, you know, what's the width on the bottom? Wouldn't you call that 16 or x plus 16? And what would you call the width, the length? X plus 12. So really all you got to do is take parentheses x plus 16 times parentheses x plus 12 and then just handshake it out. And that would be it. You'd have a polynomial and that's what they want. Yes? Liz?
But remember 46 in the book, it says here's the expression by rationalizing the numerator.
Yes. In
In
algebra, you're right. You always want to rationalize the denominator. But in calculus, you're going to find you will need to rationalize the numerator. Now, you haven't been to calculus yet, so you have to take this on faith. But actually, that's not quite true. A little bit later this fall, I'll be showing you when you really need to do that. In fact, very soon I'll be showing you that. So you're right. It seems odd because all through your algebra career they kept saying rationalize the denominator. In calc, you need it this way too. Yes. Yes.
Could you do one like 74?
Sure. So this is like 74, and what's happening there? A factoring problem. Okay. Is 73 going to work? Sure. All right, 73. Let's try that. If you don't think that's enough like it, well, we'll see what we can do from there. I think it is, actually. Okay. So how many terms do we have up there? 3. So it's not a divide and conquer. We only do those when you have 4. Might this be a perfect square trinomial? Should ask that question because that would be kind of cool, but it's not. Why not? Because 2 is not a perfect square. So right off the bat, the first and the last terms, so that's out. Could we factor out a common thing from all 3 terms? No. So we really only have one alternative left. And what I called it in my class was riddle 2. I'll explain. It's the harder riddle. we know we're going to need two binomials, so let's get set up for that. And in order to get a 2x squared, one of these guys is going to have to be a 2x, and the other one's going to have to be a 1x, and that's what makes it hard. You can't do the riddle in your head now. We do know that these two guys that are missing have to multiply out to 10, and the good news is there's only two pairs I can think of that do that. 5 and 2, or 10 and 1. And usually, by the way, I advise, always start with the ones that are closer together. Just almost always will save you time. So I'm going to start with 5 and 2. Now, if I do it this way, will it work? Well, inner product is 5x, outer product is 4x, and 5x and 4x, adding or subtracting, just don't make 21. Okay? So let's try reversing the 5 and the 2. Let's see if that does it. This time you have 2x and 10x, and 2 and 10 don't make 21 either. All right. What?
Can't you just 73 instead of 2 and 5?
No. See, you got to have two numbers that multiply out to 10. Yeah. So that's okay. This all is not lost. That means maybe we got to use the 10 and the 1. Okay. And sure enough, if you play around a little bit, look, the inner product is now 1x, the outer product is 20x, and 1x plus 20x is 21x. Aha. And everything's positive, so we know we got that. And now, before you get too giddy and move on to the next problem, you always got to stop and go, wait a minute, can I do any more here? And sometimes, you know, like on the quiz, I might have given you a factor that was x squared minus 4, which you could have then factored. But this one, I don't see any more you can do. So most likely that 74 probably was a riddle 2 job too. Yeah. And do you see it's okay to fail a little bit when you do that? If you think I did that in a very disorganized way, honest, there isn't a whole lot more you can do. It's okay to write a couple things down and erase them. It's okay. Riddle 1s you should be able to do in your head probably, but riddle 2s, you really need to do some trying like that. All right, next. Other test-like things you want to go through? One more, yes. I doubt it's stupid. No.
Okay, it's like just throwing some. If you have a number on top and then an x to like the third, and on the bottom you have another number, that would be like divisible. Let's say you have like 6 on top and 12 on the bottom, or 12 on top and 6 on the bottom, something like that. And then on the bottom you would have x and 6. Right? What would you do with the exponents?
Well, you just break this into two parts. 6 over 12 is just 1 over 2. And then what's x cubed over x to the 6? Keep the base and subtract the exponents. So you could write this answer like this, or you could write it like this. Depending on whether the book said, hey, I don't want any negative exponents in the answer, then you would answer it like this. And if they don't say that, this would be perfectly okay too. So I like to kind of compartmentalize them. Put the numbers in one little problem, put the variables in another, kind of do them separately, and that's usually a pretty good way to do that. Okay, then I guess and what I'm going to do is start chapter 1 then. Anybody else questions? So next time on Friday when you come to class, I think the first thing I'm going to do is collect the test. Okay? So we won't be doing questions anymore. You want to come and see me? That's fine. I don't mean to cut off questions. I just don't think we're going to use class time for them anymore. Okay. Well, moving. Okay, chapter 1. Now, just a general comment. Because we've been reviewing and review is a review of all the algebra you've had before, that was pretty compressed. Okay? So honestly, I think in the beginning of chapter 1, you're going to feel like it'll ease up now. Because we're going to be just taking one thing at a time. And actually, this stuff's pretty easy. You probably had some of this. So in a way, it's kind of ironic. As we move from chapter P to chapter 1, things are going to seem a little bit easier for a while. Now, as we get going, yes, are we going to be doing anything new? Oh, yeah. And then there'll be some challenges. But I think you're going to find right in the beginning, it will be kind of like, we've settled down a little bit here, and we won't be racing through, miles of algebra like we had been. Okay. So here we go. The first chapter is about equations and inequalities. You know what I mean by inequalities? Less than, greater than, less than or equal to, stuff like that. The first lesson in chapter 1 is graphs of equations. So we're going to be doing graphs. The first objective, sketch graphs. Second objective, how to find x and y intercepts. These are pretty easy. Number 3, using symmetry to help you graph. 4, finding the equations of circles and then going ahead and sketching them. And number 5, use graphs to solve word problems. Okay, so here we go. Some of this is so easy. All of you know how to plot points on a plane, I'm sure, so I'm not going to spend much time on that. But how would you tell if a point is on a graph? Like if I just said to you, the point -1, 3, is that on this graph? How can you find out? You plug it in and see if you get a true statement. Correct. In this case, when you plug in those values for x, first coordinate is always x, second coordinate is always y. Plug them in and what happens? You get a true statement. That tells you that point is on the graph. Okay, I know you all know how to do that, so. If I just threw an equation at you right now and said graph this, how could you do it? This is probably what you would do. You would pick some values for x, you'd plug them into the equation I gave you, and you would see what y came out to. And then you would take the x and the y, and you'd make a point, and you'd put a bunch of points together, and you'd try to sketch it, right? And yeah, that last one, be cautious when you connect them. I've seen people that had points that were all over the place, and I don't know, there are some people that think everything has to be straight, and it's like they took a kindergarten pencil and went like that, and you got to remember that most things are not like that. Most things are flowing and smooth. There are exceptions, right? This guy, absolute value function, is an exception. It's got a sharp corner in it, but I mean, otherwise, generally speaking, the things we're going to be dealing with have curvature to them. Okay, so here's an example. This person was asked to graph y equals -2x plus 3. So they just picked some points, and by the way, good advice, if you're going to do that, it's good to always pick 0 for a couple of reasons. 0 is very easy to calculate with. Secondly, it's a good point to have on your graph. Where does this thing cross the y-axis? It's good to know. That'll always happen when x is 0, right? So you're finding the y-intercept. And then always pick at least a couple of positives and a couple of negatives. Why? Because you want to know what happens on both sides of the y-axis. Okay? So just advice. Get 0 in there. It's wonderful to work with. And get some positives and some negatives so you get a little balance. Actually, 5 is an absolute minimum. if you're really wondering, wow, what happens over there, that's starting to puzzle me, pick a few more values for x and find out. So then plot the points. Everybody in here knows how to plot points. Then sit back, look. Is there a pattern? In this case, there's a definite pattern, and it shouldn't surprise you at all that these are lined up. What clue was there ahead of time that you knew those were going to be straight? Yeah, tell me, how do you know it's linear? That's right. No exponents over 1, exactly. And well, there's one other little thing. You know, if you just have like xy equals 5, that seems to be straight and it's not. But you're right. The exponents is the big clue. In fact, did anybody, when they looked at negative 2x plus 3, did anybody in here think mx plus b? That's good if you did, because that's another big tip-off that it's a straight line. So here's another one. This time the points are curved. This is a famous curve too, called a parabola, and it should, maybe this was obvious to you too, because the highest exponent was a 2. One variable is to the 1 power, and one variable is obviously going to be to the 2 power after you square that out. Yeah, then another, kind of special creature that keeps coming up is the absolute value guy, and he's the one that has that right angle bend in him. That's the only thing we're going to be studying that ever has a corner in it like that. This particular one is shoved up 1. What is it that shoved it up? +1, yeah. Okay. All right. Where a graph crosses the y-axis and where a graph crosses the x-axis are called intercepts. We call the place that crosses the y-axis the y-intercept, and the place that crosses the x-axis the x-intercept. How do you find intercepts? If I just give you an equation, how do you find the intercepts? Well, the answer to the question is kind of tied in with this question. What is true of all ordered pairs of points that lie on the x-axis? Any point that lies on the x-axis, it'll always look like 0, something, right? 0, 9, 0, 8. Those are all points on the y-axis, right? Okay. And how would you find y-intercepts? Wouldn't you just set x equal to 0 and solve for y? Yeah. What's true of all points on the x-axis? They are all in what format? Some number, goose egg, right? 0. Right? And so how could you find x-intercepts? Set the y value equal to 0 and solve for x. Okay. I know you've done that before. Those are good things to do, because those are relatively, when you set something equal to 0, it's wonderful to calculate, right? Because it drops out and it usually comes out to a very simple calculation. So here's one. Let's quick do this one in our heads. You got x squared plus 4x minus 5 equals y. Let's find the intercepts. Okay, the y-intercept is really easy. How do you find the y-intercept? Set x equal to 0. Goodbye, goodbye. What's left? -5. So what's the y-intercept on this? 0, -5. Okay, so already we know, all right. Now, that's going to be a little harder doing the x-intercepts, isn't it? Because now I have to set y equal to 0, and I have to solve for x. Well, good old factoring comes to the rescue. And it turns out there are 2 x-intercepts. One is at +1, one is at -5. Does that surprise you? that a parabola would have two places where it crosses the x-axis? No, and you know how parabolas look. They're going to cross in two places. And it only crosses the y-axis at one. Yeah, that makes sense. Well, now with those 3 points, you could actually sketch that thing, couldn't you? As long as you don't do the thing, you're okay. Okay. Yeah, this is just saying, hey, that's not a bad way to get a quick and dirty graph. Find the x and the y intercepts, plot them, and you might even have enough to sketch it right from there. And so if you really were in a hurry, it'd be at least a good place to begin. All right, let's get on to symmetry. There are some rules. I want to see what you remember on this. Symmetry, first of all, do you understand the term? Symmetry refers to what? Kind of the geometric pattern of what? You've all done the art project way back in elementary school where your teacher had you maybe do some cutouts, and then she had you take the piece of paper. Well, first she had you take the piece of paper and fold it, several times, and then you took out a scissors. And first of all, you were very careful so you don't hurt anybody with the scissors. And you would do some cutting, and then you're like, big deal. And then you unfold it, and whoa. Depending on how many times you folded it, you got multiple results, and they were very symmetrical, right? How do you find out if a graph has symmetry? Well, I'll just start throwing it out. We don't have much time, but I'll just begin this. If you want to know if something has y-axis, or this is x-axis symmetry, so I'll start with that, right? The x-axis, would you agree if you folded this piece of paper along the x-axis, wouldn't you have a matching up of the top part of the curve with the bottom? So that's x-axis symmetry. How would you find out? Well, you could do this. Take your equation and pick a number for y, and then pick the same number for y with the opposite sign. Does it make any difference? You find out that both of them work. Wow, and now, of course, you can't just do one. You probably need to test about 2 or 3. That's called a symmetry test. So I'll just go through that again. Pick a value for y, and then take the same number, but the opposite sign. Do they both fit in the equation? Aha, this might have y-axis symmetry, but try 3 more. Yes, cool. Okay, one like this, and then how do you find y-axis symmetry? Pick a value for x and plug in it's the same creature with the opposite sign for x. Let me see how far along I am. Yeah, I think what I'm going to do is get you started on the assignment, even though I'm not done yet. And you guys have the test, I know, to finalize too. So here's what I'm going to have you do. On the 1.1 exercises, page 85, um, 1 to 19, do the odds. 1 to 19, the assignment goes quite a bit further, but I didn't get any further. 1 to 19 odds. Don't forget, have your test ready to go at the beginning of the period. I'll see you on Friday.